We're going to continue talking about similar figures. This time we're going to see how the perimeter and area of similar figures are related to each other. We're going to start with the perimeter. We're going to start with these two similar triangles here. And it really doesn't matter that one is the original and one is the new. So we're just going to label them A and B, like before. Just to verify that these two triangles are similar, we're going to make sure that their side lengths are proportional. So we'll just look at the ratios. We'll do A compared to B, and let's look at their corresponding parts. So 4, side length of 4 corresponds to side length of 14. Side length of 6 corresponds to side length of 21, and side length of 8 corresponds to 28. And if you reduce all of these fractions down, you will see that all of them reduce down to 2/7. And so since they are all equivalent fractions, you know that they are proportional. Now that we've verified similarity, we're going to look at the relationship between their perimeters. We'll start by finding the perimeter of triangle A. And remember, perimeter is just the distance around the figure, so we'll add all the side lengths up. That's 4 plus 6 plus 8, which is 18. And then the perimeter of triangle B is going to be 14 plus 21 plus 28, which is going to be 63. So now we want to compare the two perimeters, so let's just look at their ratios. So if I put just a little fraction bar over that, the perimeter of A over the perimeter of B, and that's going to be 18/63. If I take that and simplify the fraction, 9 goes into both of these, 9 goes into 18 twice, 9 goes into 63 7 times. What you should notice then is that the ratio of the side lengths and the ratio of the perimeters are equal to each other. This leads to the key idea that when two figures are similar, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. As long as you set up the ratio so that all of the parts of one triangle are in the numerator and all of the parts of the other triangle are in the denominator, then all of your ratios should be equal. Let's look at this example here. We need to find the perimeter of figure B if these two figures are similar to each other. We are given that the perimeter of A, don't mind the fact that the word perimeter is spelled incorrectly, is 15 millimeters. We need to find the perimeter of figure B, and since we don't know what it is, we are just going to let it be equal to X for now. We know that since these two figures are similar, the ratios of the corresponding sides is equal to the ratio of their perimeters. So let's set up these ratios. We'll start with figure A over figure B and their corresponding sides, which we know, right, is going to be 4/10. And let's simplify that fraction again to make that easier for us to solve. That is going to be 2/5. And that ratio is the same as the ratio of their perimeters. We know the perimeter of A is 15 millimeters, so that is going to be 15 over, we don't know the perimeter of B, let it be equal to X. These two ratios are equal, so let's solve. Cross multiply. X equals 37.5 millimeters. So the perimeter of figure B is going to be 37.5 millimeters. Now let's look at the relationship between areas of similar figures. We have two rectangles here, one red, one blue. Let's just start by verifying that they are similar to each other by checking their corresponding side lengths. So let's set up the ratios. R red to B blue. start with the first side length. Let's do 4 in the red shape, corresponding to 6 in your blue shape. And then the next side length is going to be 8 in red, which corresponds to 12 in blue. And let's just simplify these two fractions, and when you do, you should see that both of them simplify down to 2 over 3. We can see that their corresponding side lengths are proportional. That means that these two rectangles are similar to each other. Now let's compare the relationship between their areas. So we'll start with finding the area of your red shape, and area is just going to be length times width, so it's going to be 4 times 8, which is 32. The area of the blue is again length times width, 6 times 12, that is going to be 72. Now let's compare their areas by looking at the ratios. So the area of R over the area of B, change that into a fraction, so that's 32 over 72. If I reduce that fraction, 8 goes into both of these, 8 goes into 32 4 times, 8 goes into 72 9 times. So now you will see that the ratios of the side lengths and the ratio of the areas are not necessarily the same, but if we kind of play with this a little bit, we can see some sort of relationship. So if I do 2 over 3, okay, let's think about it. What can you do to the 2 to make it become 4? Well, doing that same thing to the 3 will get you 9. All right, and if you said square it, you are correct. So if I take 2 over 3 and square it, I will get 4 over 9. So the relationship for areas of similar figures, though not as obvious as the relationship for perimeter, but a relationship still exists, is that when two figures are similar, the ratio of their areas is equal to the square of the ratio of their corresponding side lengths. Now let's look at this example here. It says find the area of the red triangle if the two triangles are similar to each other. To start, we need to figure out the ratio of their corresponding side lengths. So we will go red to blue to set up our ratios, and we have our corresponding sides, right? 6 in the red is going to correspond with 10 in the blue. And again, reduce this fraction, that is going to be 3 over 5. So now we want to find the area of the red triangle, which we don't know, so we will just call it x for now, but we are given the area of the blue triangle, which is 125 square units. Let's start by setting up the ratio. Again, R, red, to B, blue, of the areas is going to be x, which we don't know for red, but 125 for blue. And we know that the ratio of the areas is equal to the square of the ratios of the corresponding side lengths. So to set up the proportion, we would do x over 125 equals 3 over 5 squared, which equals 9 over 25. So I will just rewrite this so it's cleaner, and then we will solve the proportion. You can solve it in any way you see fit. I will just cross multiply. 25x equals 125 times 9 is 1,125. Divide both sides, and you should get that x equals 45 square units. So to answer the question, the area of the red triangle is 45 square units.